Hello, so let us now calculate the mean of the hypergeometric random variable. So just a recall that the probability mass function or the PMF of a hypergeometric random variable is given by this expression where our n goes from 0 to n and our r goes from 0 to k. Okay, and n is any natural number and k also goes from 0 to n. Okay, so now what is the definition of expectation? So we start with the definition. We have this is summation r times n r n minus n k minus r divided by n choose k. R goes from now actually r goes from 0 to k, but I'll write r is equal to 1 to k because if I multiply by 0 here, this summation goes to 0 and that does not contribute to the sum. Okay, now what is this guy? What is r times n choose r? This is equal to n times n minus 1 choose r minus 1, and this can be proved easily by using just the definition of combinations. So let me write this as r is equal to 1 to k. I'll write n outside, so n minus 1 r minus 1 n minus n k minus r divided by n choose k. Okay, now let me do a change of variable here. So I'll say m is equal to r minus 1, which means r is equal to m plus 1, and if the range of r is from 1 to k, the range of m, which is 1 less than r, should be from 0 to k minus 1. So now let me write this again. I'll write n and I'll write this n choose k also outside, okay, because the summation variable is not there. So I'll write m is equal to 0 to k minus 1 n minus 1 m, and then I'll write for n minus n, so let me manipulate it a little bit. I'll write n minus 1 minus n minus 1, and then here I can write k minus, for r I will write m plus 1, so I'll write minus 1 minus m. Okay, and then I have this part. Now note that this is exactly the same as our hypergeometric distribution formula here, but the parameters are changed. So now what is the probability mass function of a hypergeometric random variable with these parameters k minus 1, n minus 1 and n minus 1? So for that one I will write probability x is equal to m, this is equal to n minus 1 choose m, n minus 1 minus n minus 1 choose k minus 1 minus m divided by n minus 1 choose k minus 1. And if I do the summation here, if I use this expression and I will go n over n choose k, then m is equal to 0 to k minus 1, and I will just copy from there n minus 1 minus n minus 1 choose k minus 1 minus m, and then if I divide it by n minus 1 choose k minus 1 and multiply by n minus 1 choose k minus 1, then this guy is just sum of the probability, all the probabilities of a random variable. So this is 1. So then I'm left with n times n minus 1 choose k minus 1 divided by n choose k. So then again, if you use basic definition of combination, then you will end up with n times k over n. Okay, so this is actually the mean of a hypergeometric random variable with parameters n, k, and n. Okay, so then again in summary, we used couple of techniques. One technique was to see this formula in which we just manipulated the combinations. The other technique was change of variables in the summation. And the third one was noting that this expression can be written in terms of a hypergeometric distribution of some different parameters. Okay, so hope it was easy to understand how to calculate the mean of a hypergeometric random variable. And thanks for watching. Hope you liked the video.